You get it? Okay. Okay, so today I want to talk about something called completing the square. And so the reason I want to talk about it is I have a suspicion that this might be a better way of factoring a lot of problems. And I could be wrong, but let's try it out. So you guys are my guinea pigs, if you will. So to start with, though, I need you to indulge me, if you would. I have to do something a little bit theoretical. It's a little bit abstract looking, all right? But just bear with me. I'm describing a general process that we can do, and then I'm going to do a bunch of examples. But I need just to keep it a little bit sort of abstract here for a second. So I'm going to work with this A, B, and C, which are given, and I'm going to go through some steps. So number one, I'm given this, right? And I'm going to factor out A. So f of x equals to A times x squared plus b divided by A, x, plus c over A. That's my first move. Then next, I'm going to notice that x plus b divided by 2 times A, if I square this, I get x squared plus b over A plus b squared over 4a squared. Okay, so what that means is I can take these two terms right here and see that there are these two terms like that, right? So I can rewrite what's underlined in orange as follows. Notice. Or note. Observe, whatever you like. Let's see here. So this is really x plus b over 2a squared minus b squared over 4a squared. What's that? I will slow way down once we get to the examples. But I'm going to move on here. Oh, you guys have distracted me because I was supposed to add c over a to that, plus c over a. It's okay, I blame Kennedy. All right, c over a. So look here. So at this point, this is what's called completing the square. Or you could say the square is completed. In the sense that what you've done is you've lumped all of your variables, which in this case is x, right? You've lumped the x into a single term, which is squared, all right? And why is this helpful? Well, 3 b squared, let's see here, b squared over 4a squared minus c over a is equal to b squared minus 4ac divided by 4a squared. So we have f of x equals to a, big parentheses, x plus b over 2a squared minus b squared minus 4ac. Yeah, you can take a picture if you want, that's fine. Like that. I will explain it.
Thank you, because I'm so lost. I don't know where to start. I don't know.
Just hold on here for a second.
Math is stressing me already.
Do not stress. So look here, guys. Now, if well, then we can do what? We can say this is equal to a times x plus b over 2a squared minus the square root of b squared minus 4ac. Was that Kennedy? That was Kennedy, wasn't it? Let's see here. I knew that without looking. Let's see here. I'll point that out. 2a. I recognize that. That sound. Let's see here. Everyone's got to have their signature move, you know. Let's see here. So, okay. So, what I've done is I've rewritten this as what? This is now a what? So, well, the square was complete back over here. What I'm trying to do now, what? Is this the what?
I told you, bro. I'm stressing your class.
Just calm down. It's all going to be okay. So this is the difference of squares. I have this squared minus that squared, right? You've seen this on TikTok.
I got a question. This is like not exactly about this, but it's about this class.
Well, let's save that question for just a couple minutes later. Let's see here. So this, I mean, it's fine, but just hold on for a second there. Hold that thought. So this is x plus b over 2a minus the square root of b squared minus 4ac divided by 2a, x plus b over 2a plus the square root of b squared minus 4ac divided by 2a. All right? Which you could rewrite this a little bit more neatly. This is x plus b minus the square root of b squared minus 4ac over 2a, x plus b over 2a plus the square root of b squared minus 4ac. Do you guys? Yes. 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 But not not in this way. It will be on the quiz, but not in the way I'm doing it right now, because that would be very silly. Just please be patient with me for just a couple minutes here. So if we have f of x equals to 0, right? So what I've done is I've gone through these algebra steps, right? I've taken the time to rewrite the given polynomial as a difference of squares, and then we use the so if this is like, if you look at this as alpha squared minus beta squared, that's alpha minus beta times alpha plus beta. So you could think about this as like alpha squared, and you could think of this guy as like beta squared if you like. So it's a difference of squares. So we have alpha minus beta, alpha plus beta here. What happens if we set f of x equals to 0, right? We try to solve the polynomial equation. What does that give us? So we have to have this is 0 or that 0, right? So x plus b, plus or minus the square root of b squared minus 4ac divided by 2a has to be equal to 0. What's that tell us? Because it is the quadratic formula. This is the derivation of the quadratic formula. Derivation. Derivation? A derivation is yes. A derivation is a mathematical argument that shows one truth comes from another. In particular, this is a derivation of the quadratic formula from just regular. Yeah, pretty much.
My question was, if I try my hardest in this class and I still fail, will you give me an NA?
An NA? What's that?
That's the thing that it like, it doesn't fail me, but it like, I've got to repeat the class, but it doesn't hurt my GPA.
I would have to look into it. I mean, I wouldn't rule it out.
Okay, look, I'm not gonna lie to you. I was about to drop this class, and my advisor was like, well, teachers are allowed to give you an NA, which means if you actually try in there, then they give you an NA. You have to retake it, but it won't hurt your GPA.
Well,
That's
but
the only reason I stayed here off of hopes that I can get it. I'm trying.
I wouldn't be opposed to it, but I need to know. I don't know what that is here, you know.
Okay, I will get the advisor to
Sure.
I'm gonna tell my advisor.
So, go on. Yeah.
Okay, so is the quadratic formula going to be what's on this
No.
physics quiz?
No.
So the debate's going to be on the quiz?
No. Wait. Hold on a second here. Listen. You listen. So the point of this is that, this quadratic formula, like this is at the very end of the course, like chapter 7 has homework on this, okay? But, okay, we'll get there. But what I'm trying to tell you is that you can actually use this idea as a method of factoring. Let me show you what I mean. In other words, the reason I've done this is so that now we have derived the quadratic formula. I will not do it again later in the course. We've done it now. We can refer to this later. That's why I did that today, okay? What? Okay, so now what I told the other section of intermediate algebra is, yes, I'm going to test on completing the square for you guys, but I'm going to make it easier. I'm going to guarantee us that when I ask you completing the square question, I'm going to make sure a is just equal to 1. So that's going to make life a lot easier here because we don't have the factoring the a step out, and we just got numbers to deal with. All right, so let me show you how this goes. Because the larger point here is I don't actually want you to use the quadratic formula. I want you to essentially find a way to become the formula in some sense through algebra. And let me show you what I mean by that. So let's just start working examples now. So let's see here, x squared plus 4x plus 3. So what I'm proposing is that there are two ways of factoring. And so here's my claim. This is what I'm going to show you. So given ax squared plus bx plus c, you can either guess factoring, or you can complete square. And use alpha squared minus beta squared equals to alpha minus beta, alpha plus beta, so to speak. The reason I'm not using a and b, I usually use a squared minus b squared as a plus b times a minus b. I don't want to do that because I used A and B for the formula of the quadratic. That's all. That's the reason. That's why I've introduced the alpha and beta. It's just I don't want to reuse A and B. Don't. I'm sorry if I erased it before, but I'm sure I'm sure Chris got it in frame, right? Come back, come back. Focus on this. I'm going to do an example now. I've gotten through I have gotten past the theoretical, what's the word? Discussion. Do not give up. Look. All right, guys. So here's the algorithm. All right, so number one, given x squared plus bx plus c, all right? I'm putting a equal to 1. That's the first point. We have to be given that. Number two, we rewrite that as x plus b over 2 squared minus b squared over 4 plus c. And then step 3 is use differences. Difference of squares.
Could you use 4x and 3 so I have to be more understanding? Because I'm lost.
Use what?
4x and 3, right? Why are you switching to bx and c?
Basically, he said.
This is the algorithm. This is going to be like generally true. So I'm just leaving that there. I'm going to do this again and again and again. So here, b is 4, so I'm doing x. I take half of that, which is 2, right? I square that. Then the thing is, by doing that, I've added 4. Because 2 squared is 4, right? So there's like a 4 in x plus 2 squared that was not there before. So to be fair, I have to subtract b squared over 4, which in this case is 2 squared over 4, which is, well, 16 rather. B is 4 here. So 16, anyway, I have to subtract 4 is what I'm getting at here. 16 over 4 is 4. And then I still have the plus 3. No what? Don't understand. Okay. So what's going on here is x plus 2 times x plus 2 is what? Uh-huh. Right? So this one?
This side.
For here?
Yes, where's that come
2 times 2? The other one's FOIL. I mean, it's 2x plus 2x, which is 4x. Just multiplying. Is that it? So what I'm pointing out to here is like this is what's here, right? So if I want to rewrite that as this is x plus 2 squared, right? So if I take x plus 2 squared and I subtract 4, it's equal to x squared plus 4x. So what I'm trying to say is what I have right here and what I have right there, they're the same. The difference, of course, is that on the right-hand side, I have the square, I have x in the square. I don't have just a plain x term sitting there. Let me close the door here. Come on. So this is x plus 2 squared minus 1, which we could write as 1 squared, like 1 is 1 squared, right? So, I mean, I'm just emphasizing that this is the difference of squares, right? So I can go back and I can write that as x plus 2 minus 1 times x plus 2 plus 1. You don't follow? So again, alpha squared minus beta squared is alpha minus beta times alpha plus beta. That's the difference of squares. So alpha squared minus beta squared, alpha minus beta. Right, because when I multiply that out, I get back to there. This is beta. This is alpha. Aren't you guys in like Greek organizations and such? No? But you have friends, right? You want to understand them, right? I could change it to Pac-Man and Ghost if you like. I mean, it doesn't matter. I mean, Pac-Man squared minus Ghost. Mostly, yeah. Is that better? No, it's not better.
I'm already few with X thinking.
All right. Okay. Yes. Uh-huh. Right, so what we have now is... Mm-hmm, right. Yeah.
So every number we get from this goes right here, correct?
Right.
Okay, and then if it's positive or negative, if it's positive, then that would be positive and that would be negative. Right?
If it's negative, then we can do difference of squares.
Okay, but if it's positive,
If it's positive, that means we can't reduce it.
so it just stays like that.
It's prime.
Oh.
Yeah, we're getting there. So your question is ahead of the game, so that's good. Now, now I have some bad news though, which is that what?
I was just happy. I was just happy.
No, I mean it's good. But my question is this the right way to do this problem?
No,
Why?
because it's too long.
Because it's too long. I know that's because you guys keep asking questions. So
You get a guess.
you could have guessed, right? So his point was Hayden. So Hayden said, well, this is like taking candy from a baby. This is just x plus 1 times x plus 3. That's an easy one. You can't have candy? Oh, well.
You got a bad liver.
Really?
He's gonna die when he's young. He's gonna get drunk.
All right, so, but yeah, I would say that this example, it's simple enough that factoring was pretty easy, right? So that's like a reasonable way to do this problem would just be to just look at x squared plus 4x plus 3 and do our usual thing, right? But there is something fundamentally different about the completing square thing I just showed you in that, which is what do we do here? I mean, how do you, this is 3 times 1 or minus 3 times minus 1, right? So you try plus 1 and plus 3 and, well, great. And it's right, and that's what we derived. But there's a difference between the completing the square way and that guessing way, which is there was no guessing here. We just follow this algorithm, and it automatically produces the factorization. Do you see that? There's no guessing.
No, I think I might understand just a little bit. I want to make sure I'm right. Okay,
Uh-huh.
So don't erase the bottom part that you just did. So x squared plus 4x plus 3. So put like the last number 3, right?
Yeah.
So you have to multiply after that, but you also have to add it to make sure the middle is correct.
That is correct, yes. We have to multiply 1 times 3 to get 3. That's a good check. 1 times 3 to get 3, and 3 plus 1 has to be 4.
All I need to know.
No, that is good.
That's all the thing I know.
No, that is good.
Okay, so with 3, you're multiplying the last part. We also have to make sure both of them are negative 4. If we both x minus 1 to x minus 3, which is going to be positive 3 at the end, we got to make sure it'll be negative 4 in the middle. So whatever you multiply, it has to add up with the same sign. Be in the middle.
So, all right. So, I need to tell you some different cases. All right. So, when we complete the square, there's 3 different things that can happen, right? We can get minus a number like we just got. I mean, if you think about it, basically this b squared minus 4ac thing. Oh man. So b squared minus 4ac. There's 3 things it can be. Oh, come on. Seriously? All right. So we're either going to get something like something squared minus a number, something squared plus a number, or you just get something squared. These are the 3 patterns that can happen when completing the square. So this pattern, it happens when b squared minus 4ac is greater than 0. This happens when b squared minus 4ac is less than 0. And the last one happens when b squared minus 4ac is equal to 0. So those are the possible cases. That's the pattern that we're going to see. We just saw case number 1. I'm going to call this case number 1, number 2, and number 3. Right? So something like this, x squared plus 1. We've talked about this before. Can we factor this? No, this is prime, right? Because to factor this, what do we need? Do you remember what we needed to factor this? We would need to use plus and minus I, right? So this only factors over complex numbers. This is prime. So, or you could say it's irreducible. Let's check. What is B? What's A? What's C here? A equals to what? B equals to what? C equals to what? What's B for this one? 0. All right. A is 1. So what's b squared minus 4ac in this case? What's that?
Okay, so you got to plug in everything. So 0 squared is 1.
Uh-huh.
And then negative 4, 3, negative 3, negative 2.
Right. So we got minus 4, right?
Yeah.
So the discriminant is minus 4. That means that we're in case 2. It's like something squared plus a number. Of course, the something squared here was x. We didn't even need to complete the square. Like, completing the square is stupid in this case. There's nothing to complete. There's no linear term to get rid of. The whole idea of completing the square is to remove the linear term. We want to get rid of that bx term and like lump it into the squared term. That's the idea. See that? Like, completing the square got rid of this pesky, annoying linear term, and it brought it into the square. That's the magic. Example 3. If we have x squared plus 6x plus 9, right? We complete the square. We take x plus 3 squared, right? And then we're supposed to subtract the square of that. Whatever number it puts here, we subtract the square of whatever goes here. So I do minus 9. This plus 9 is still here. So minus 9 plus 9, also known as 0. Yeah, so that's it. It's factored, right? No, this one's reducible because we just factored it into. Write it out this way, right? It's factored. It's just like this, right? You can't go further than that. That's game over. Once you got linear factors, you can't go further. Yeah, and exactly. If we multiply that out, we get 3 plus 3, which is 6. 3 times 3 is 9, which you're talking about, right? We could double check. This is case what? So what's b squared minus 4ac here? Well, let's figure that out. A is equal to 1, right? B is 6. C is what? So we've got what? We've got 36 minus 4 times 1 times 9. That's 36 minus 36. That's 0. 4 times 9. 6 squared is 36. 4 times 9 is 36. They cancel. So if we go back, Chris, is this in frame?
I moved the camera to right there, but trying to help my buddy over here.
Why? How is that?
Trying to get
Oh. Quit smoking with. What's this? Sunflower seeds. Okay. I gotta make sure you guys aren't chewing in class. It's not allowed, you know. All right. Okay, that's good.
Yeah, no, I'm trying to quit.
Did I ever tell you guys I had a professor who dipped?
Yeah.
Okay.
My high school teacher.
What?
Wait, can you tell us
Yeah,
the story
you're
again?
No, I think I told it before. I don't do reruns.
I don't remember you talking about. I don't remember hearing it.
You remember? You can go back, watch the tapes. Let's see here. So I've covered all 3 cases now, right? If we get a number, minus a number, right? We can do the difference of squares things to factor it. If it's 0, it's already factored. It's a square. And if it's plus a number, that means that the polynomial is one of those ones that you just can't factor. All right? And the reason I'm talking to you about this as opposed to factoring is this is like a method. There's no guessing. So when the answer involves like ugly fractions or something, we can still do completing the square. We can discover factorizations, which would require much more sophisticated thinking in the guess and check way of doing things. But my larger point here is, it doesn't matter what you guys give me. We can complete the square on it and find how it factors or doesn't. You guys can give me any numbers. We can do it.
X squared plus
All right, just a second. X squared, yep.
28x
28x, all right, gotcha.
equals 56.
Minus 56 then.
Yeah.
All right. So I regret writing it there, right here. X squared plus 28x. I think that one's not too bad, though. We'll find out soon. Is this a homework problem?
No, it's not homework.
Okay.
I just guessed.
It's a way that I'm trying to get my homework done. Oh, wait, you talking about what we were talking about?
All right, so complete the square. So we take half of whatever's the linear term, which in this case is 14, right? Now, when we do that, remember we square it. Now, the whole point of that was when we multiply that out, we FOIL it out, if you like, that gets us back x squared, it gets us back 28x, but it also adds 14 squared, which is 140 plus 4 times 14, which is 196, right?
Okay, I'll see if I can name.
Is 14 squared 196? Somebody check me on that. Sounds about right. Okay, good. And then what do we put those together? What we got? 252?
Yep.
And then here's the thing. We are in case what? We're in case number 1, right? Yeah.
Sir.
So now you just got to use your imagination and write it as a difference of squares. So how do you write 252 as a square? I take any positive number and write it as a square. Yeah, square root. This is. Did somebody just say Squidward? Let's leave SpongeBob out of all this. Let's see here. So, right? Now we have the difference of squares, and we can write this as x plus 14 minus the square root of 252. Aw, man. X plus 14 plus the square root of 252. No guessing. There's no guessing. That's factored. How long would it have taken you to guess x plus 14 minus root 252 times x plus 14 plus root 252, right? My point to you is we could not have factored that using guess and check, right? But we can do it with completing the square, and it's actually not that hard, right? I say it's not that hard because we don't have to do any kind of guessing. My point to you is what I was doing last class with like looking at factors and seeing how they multiply to, the usual factoring. I think that's much more clever than this, in the sense that when a method involves educated guessing, you've got multiple options, right? With completing the square, there's not multiple options. You do this, then this, then this. Or you find out you can't do anything because it's a plus, or it's already factored because it's just a plain square. So I really am not joking when I tell you that I think this is like an easier method of factoring than regular factoring. I don't know why we don't teach it this way.
So, like, have you done it? Is this the way you've always done it?
No,
Like,
no.
you just figure out.
I'm just coming to this realization. Like, I avoided completing the square because I learned the quadratic formula and I could work backwards from the quadratic formula to completing the square. That's how I would do it. I would actually, this is how I would do it. I would take the quadratic, I would find the quadratic formula, find the answers to it, and then use that to write down x minus that times x minus that as the factoring. That's how I would do it, which is foolish. Like, there's a much better way, which is to essentially what we're doing when we're completing the square is essentially going through the derivation of how the quadratic formula is derived. And so you're essentially, this has the wisdom of the quadratic formula without the annoyance of remembering a formula and plugging numbers into it blindly. All right? And like, so you guys can do this arithmetic if you're careful and you'll get it right. If you just try to use the quadratic formula, I don't think it'll go well, because there's ways you can check yourself here as you're going, right? You can ask yourself the question, is this really equals? That's something we can double check. Think about multiplying this out. Think about, do these things cancel out so we actually get back to here or not, Example 5.
You got any paper towels in there? My leg is on fire right now.
X squared.
Oh my God.
That's alcohol on it.
You got paper towels?
What on earth? What have you done?
Strawberry rash.
Yeah.
What?
It's like burning pretty bad.
Oh, really? I mean, we got those wipes up there.
It got alcohol on it.
That'll clean it though.
I mean,
Clean it all right, but it's gonna burn.
I wouldn't. Yeah, there's no telling what they put in there. I would not put that. Yeah.
It's already on fire.
No, I don't have paper towels.
If there's multiple methods of teaching something, no, you just teach us easy ways to get it over with.
Well, I don't think that this is always. I mean, I think you got to decide. Here's the thing: if you can see how to factor it, that's faster. Like Hayden saw the x plus 3 times x plus 1 for that first example. That's going to be faster if you see it. But if you're stuck on it, you can always. If you're stuck on a factoring problem, you can always fall back on completing the square, and it is ironclad. Like, there's nothing that escapes it. Yeah.
So, x minus 1, x plus 5. Then,
Oh.
yeah.
Oh, well, we could try that.
Never mind, that's a positive. I actually think it's a negative side.
Yeah.
Keep it, whatchamacallit.
Oh, yeah, if I had a minus here, you'd be, you're, well, that's the thing that's so messed up is all it takes is just changing this problem ever so slightly, just like you said. This is what you just said. So, Chris, you're exactly right. This is the factorization of that polynomial. You're not wrong. I mean, straight up, that's right. But that's because there's a minus there.
The wrong side. Okay.
It is perverse how changing one sign on a coefficient completely changes the nature of the problem. It's true, though. So I advocate.
I promise I seen the negative side first.
I don't doubt it.
So we'll be using the second thing, right? So there's a
Yeah, I think we should try completing the square. So you guys tell me out. I'll start out x. Yeah, you tell me. Well, you got to do it on the quiz Thursday. 2, yeah. Plus 2. We squared, right? I mean, that's. And then, so we have to subtract what? Remember, we subtract the square of whatever we put here. That's what we do.
4.
Mm-hmm. And then we still got plus 5, right? So we get x. So we got x plus 2 squared plus 1. Game over. This is irreducible. It cannot be factored over the reals because it's the sum of 2 squares.
This is me in conversation. I can understand this.
You're fine.
Okay, so when this problem, okay, so when we make it to this, and you put the 2, because I got that by dividing, because
Mm-hmm.
because I looked at that problem, so you got that. And so when you put that, do this, you basically put that except minus.
Well, it's not from that. It's from the square of this. Let's look at another. Right, 2 squared is 4. It happens that this matches that, but it wouldn't have to for another problem. Like over here, this is half of 6, but we subtracted the square of that. So notice the 9 and the 6 are different. So it's not, this doesn't match that. It's the square of this has to be subtracted right there.
Okay, and then you do what that equals.
Yeah, this is just left over.
I'm talking about in general.
Mhm.
What that equals, and you put that right there, and then
Right.
depending on if it's positive or not, you either do that or you end like that.
Mm-hmm. You got it. Let's do another. Now we already did we already did the trinomial stuff in here before, right? Like I did a cubed minus b cubed and a cubed plus b cubed last time, right? Good. Example 6. Let's try x squared plus 26x plus 1. So first of all, we can give up on regular factoring. It's not going to work. So you guys tell me what x plus what?
You say you gotta take half of it off?
Uh-huh. 13
Less 13?
plus 13. I square that. 13 squared is 169. So I have to subtract 169. This plus 1 still there.
So,
Which is?
negative 168. How you get a 3? I thought it was 13.
It's still in the chalk. There we go. Thank you. Yeah. Scary for me too. So I think, so this is really the square root of 168 squared, right? I just write that to give myself, I'm looking at this as difference of squares. So again, x plus 13 minus the square root of 168. X plus 13 plus the square root of 168.
You can't do anything with that.
Factored, yeah. And check it out. If we wanted to solve the corresponding equation, how would you solve this? How do you solve the corresponding equation? Like if you know the factoring, then you can solve the equation very nicely. See, because for this to be 0, it means that that's 0, right? For this to be 0, we either have to have x plus 13 plus or minus the square root of 168 equals to 0, or we have to have x plus 13 plus the square root of 168 equals to 0, right? Which either gives me x equals to minus 13 plus or minus the square root. Oh man, 168. By the way, that's what the quadratic formula would spit out. If we were to use the quadratic formula, that would be what it spit out. I suggest that we don't need to use the quadratic formula because we can factor properly. So, I mean, I'm not saying that you can't use the quadratic formula in here. I'm not saying that at all. You can use it if you want. If you use it with understanding, that's fine with me. I mean, I'd be delighted. But it's a kind of pesky formula, right? I mean, we could. Another example, yeah.
Do you think the water fountains are working right now? I got a job though.
Mm-hmm.
You think the water fountains are working? Can I go see?
I mean, what kind of water fountain are you talking about? Like to drink from, or
No, you know, some of the water fountains are locked.
I mean, for drinking or for beauty?
For drinking water.
Or like water drinking. I mean, there's other kind of like decorative fountains, you know.
Well, can I go see this?
Go drink from the fish. Drink from the fish tank. That's funny.
That thing green in the month.
That's messed up. I mean, like,
I'm just going to the water fountain.
I feel like if I had a lot of money and I wanted to do fun stuff with money, I'd be like, pay people $100 to take a drink from the fish tank, you know? It could be fun. All right, I need another example. What should I do? Fine. X squared. I might come back to it if Kennedy allows it. I don't know. Let's see here. This is x. I'm sorry. I seem to have done the first step. X plus 3 squared. And then I do what? I subtract. Yeah, it's minus 9, and then still the 2, right?
That water fountain right back. I'm doing that.
It tastes like flies.
I don't know how flies taste like that. You never ate no fly.
So-
Tell me you ain't never been around and had a bug fly in your mouth.
I was like young. I was like 5 or 6. Yeah, I remember that.
No heat.
Ew, this man they tell us already. I'm gonna sue the school if I throw up. I know what happened. When we supposed to make me too rats off it.
So if you wanted to solve the equation, x squared plus 6x plus 2, what would the solutions be? Is there something you disagree with, Kennedy? Does that make sense? If you wanted to solve the equation x squared plus 6x plus 2, can you tell me what the solutions are just from looking at what's here? I mean, be careful, because notice that when we put this and that equal to 0 and that equal to 0, we end up flipping the signs. Like the plus 13 became minus 13 when we move it to the other side. So, right, mhm. So minus 3 plus or minus square root of 7, yeah. Because for this to be 0, it means either x plus 3 minus the square root of 7 equals to 0, well, plus or minus that is equal to 0. I'll do fine. So when I solve for x, I get minus 3 plus root 7, or minus 3 minus root 7. But yeah, I mean, this is nothing new, right? Before, if we had, so, x minus 1 times x plus 3 equals to 0, then that has solution x equals to 1 and x equals to minus 3. Those are the solutions, right? Yeah, that's part of the exercise sheet we were working through. Like the first 20 of them are factoring, but then the last 10 or 12 are solve. So yeah, it's part of what we're doing. Or say there's no real solutions, right? If it's like a prime one, we can say, oh, no real solutions. At the end of the course, I think we eventually, in Chapter 7, start looking at the complex solutions there. So it's prime if when we complete the square, we get something squared plus a number. Before, I would have just told you it's prime, we just know. I mean, that's the thing. Before you complete the square, how do you decide whether something's prime or not? I guess you could use this, you could use the discriminant. In fact, this is generally true. This is called the discriminant. B squared minus 4ac is equal to discriminant because it discriminates what kind of solution you're looking at. Discriminant. It's actually the start of a longer discussion. There's actually discriminants for other kinds of... Oh, I'll shut up, yeah. That's fun. Kennedy, you're a bad influence. I feel like you're a very bad influence. So, by the way, I was about to say something interesting, and he stopped me. Yeah. Well, thank you. So my point to you guys is through the same algebra we just did here, we could actually go back and do it on this one. You could treat x squared in the same way you did x. And if you were so adventurous to do it, you could do this. This is really x squared plus 3 minus square root of 7. X squared plus 3 plus square root of 7. And what can you tell me about the square root of 7? Is it smaller than the square root of 9? And square root of 9 is 3. So like 3 minus the square root of 7 is what? Is it positive or is it negative? It's positive, right? Yeah, 0.35. So this is positive. And this is positive. So my point to you is we actually just factored that. It's done. We can't go further than that because it's x squared plus a number. Those are prime. So that's that quartic factored into primes. But this trick only works if what? It only works if there's no cubic term. Cubic, like third order term. If I asked you to factor something like x to the 4th plus 3x cubed plus 6x squared plus 2, you should say, no, that is not a fair question. You can't ask us that. The only way I could make a question like that fair is to do something like this. Factor out the x squared. Right. And then we could figure out how to factor. Oh, I haven't done anything like this yet. Oh my goodness, my bad. Let's look at this one, x squared plus 3x plus 6. I have... Jason, you're going to like this. Where was I? X squared plus 3x. This is what I have somehow avoided. And this we cannot always avoid. Like we have to face the music here sometimes, so to speak. So complete the square. What happens? What happens when we complete the square on this one? I have judiciously, I've been careful to choose examples where we had an even coefficient for x. X plus 3 over 2, right? But sometimes if it's odd, we get fractions. We got to deal with it. That's half of 3. 1.5 is half of 3. 3 over 2. Yeah. I can do both. How about that? So minus 3/2 squared, right? So it's the same. Nothing changes. We still add half and then subtract the square, right? But now we got to do some fractions. So you can use your calculator if you're worried. This is 9/4. I'm going to rewrite 6 as 24 over 4 since I can. And what's that? 24 minus 9 is what? Yeah, so I've got plus 15, right? Well, good news. That's it. That's as far as we go for that one. Because it's prime. No, but I do want to do another one so that we have a little bit more experience with how the fractions work. Let's see here. Let's see here. How about example 9, x squared plus 7x minus 3. All right, so we do x minus, or rather plus 7 over 2 squared, right? And then we subtract 7 over 2 squared. And still we got the 3. So this definitely is going to be one that factors, right? Because we have a negative number. We just got to make it prettier before we do anything. So this is x plus 7 over 2 squared. And that's minus what? 49 over 4 minus 12 over 4. Because 3 is 12/4, yeah? So we got x plus 7 over 2 minus, what's that? I want to say 61. Yeah, 61 over 4. So we take the square root of it and we square it so we can look at it the right way. And what do we get? Yeah, x plus 7 over 2